Okay. Good evening, students. Whether my voice is audible, screen is visible. Anyone? Anirudh?
Yes, sir.
Okay. Today we are going to discuss lecture number 21, types of single phase induction motor. Types of single phase induction motor. Lecture number 21. Before get into this topic, you everybody are familiar about the operation of single phase induction motor. So here in single phase induction motor, if you take, it is having a stator, it is a winding. This winding is nothing but main winding. Okay, this winding is nothing but main winding. This is stator. Okay, in stator only the windings are available. Inside there will be a rotor is available. Okay, now this is single phase induction motor. So we have to give a single phase input voltage 220 volt. You are giving 220 volt, we are giving. If you give 220 volt, normally it is 4 ampere current get inside this winding. Okay, inside this. Now once the current is entering into the winding, there will be a flux is produced. This flux is nothing but stator flux, or we can say it is the main flux. Okay, it is the main flux. Now by using this flux, we can get the rotating magnetic field. Okay, we can get a rotating magnetic field. And normally the rotating magnetic field should be alternate. For example, if you are giving a three-phase supply, okay, instead of single phase, I am giving a three-phase supply to three-phase induction motor R, Y, B. So the waveform is alternating. Okay, the waveform is alternating. So here in three-phase, there will be a alternating rotating magnetic field is produced in three-phase. Okay, in three-phase induction motor. Okay, so because of this alternating rotating magnetic field produced in three-phase induction motor, the motor having the capability for self-starting. Okay, it is having the capability to get self-starting. Okay, in three-phase. But while you come to the single-phase induction motor, okay, while we come to single-phase induction motor, here we are applying a single phase waveform. Okay, single phase waveform. Okay, and the current is also flowing only through this waveform. Okay, only through this waveform. Since it is not alternating waveform, okay, only sinusoidal, but it's not alternating waveform, so we'll get, yeah, only one flux is produced in this main winding arrangement. Because of this stator flux produced in this winding arrangement, the motor having the, it's not having the capability to self start. It's not having the capability for self start. The reason the reason is that we are applying very minute voltage to this machine. Normally if you apply a small voltage, 10 voltage, if you apply, the motor having a rights to rotate. It will be suddenly it will start running. Okay, it will start running. But in single phase, what happened? You are giving a single phase waveform. Since it is very minute current and voltage, it is having only one waveform. So because due to this, the motor, since the supply is there, current is also be there, the motor refuses to start. Okay, refuses to start. For example, you can take a fan. Okay, you can take our ceiling fan. Okay, if you take a fan, by using the switch. Okay, this is a switch, on and off. Okay, the switch is there, and the fan, this is a fan. Okay, this is a fan. Okay, and if you switch on it, normally the current flows inside the motor of the fan, then the machine will start running. It's not starting running immediately. Okay, it will take a time. Okay, it will take more time to start. Okay, sometime we have to insert a hammer, something like a ladder or something we have to insert, and we have to rotate it. Okay, like our table fan. Okay, so this is one of the drawback. Okay, so the motor, like a three-phase induction motor, the single-phase induction motor, it is refuses for self-starting. Okay, to make, since there is only one flux is produced in main winding. Okay, so to make the motor to self-start. Okay, to make the motor, please take down, to make the motor, the induction motor to self-start, we are going for another winding. Okay, there will be another winding will be induced. Okay, will be inserted. Okay, in the construction arrangement. That winding is nothing but starting winding. Okay, second winding is starting winding. Okay, one is main winding is already available, another one is starting winding. Okay, now here, by you having these two winding, we are having a small changes in the constructional arrangement. That changes we have to make. It is the starting methods of single phase induction motor. Okay, we should not say it is a types of induction motor. Okay, the topic is wrong. Normally we have to say it is an indirect question in your examination. Discuss the starting methods of single phase induction motor means immediately you have to write this explanation and mention the steps. Okay, starting methods of single phase induction motor. Okay, but in the syllabus they are mentioning it is a type. Okay, anyway it is a type, but the normal general topic it is starting methods of single phase induction motor. Okay, so to make starting of single phase induction motor to self start, we are having here two windings. One is main winding, another one is starting winding. Okay, now for this we are giving a supply, a single phase supply, it's giving it. So there will be a one flux is produced in main winding, there will be another flux is produced in starting winding, because this main winding and starting winding both are parallel. Okay, starting winding and main winding are in or in parallel. Okay, or in parallel setup. Okay, so because of this supply, there are two fluxes are induced. One is, both are stator fluxes, one in phi 1, another one is phi 2. Okay, these two fluxes will be running in opposite directions, then there will be a resultant flux is produced. Okay, so because of this there will be a production in rotating magnetic field of the motor. Once the motor starts, immediately Okay, once the motor will start, immediately this second flux will be removed. Okay, then only the motor can rotate. Otherwise what happen, if two fluxes will be produced, it will be there in the machine, then because this the second starting one is there, right, this is only for starting purpose. Okay, starting purpose, main winding for running purpose. Okay, main winding for running purpose. Okay, so once you give the supply, there are two fluxes are produced. These two fluxes will be opposite to each other, then a common resultant flux will be produced. So once this flux will be produced, immediately the motor will starts running. Okay, the motor will starts running. Once the motor starts running, then we have to remove the second flux. Okay, phi 2 or either one flux we have to remove, then only the motor will starts running continuously. Otherwise what happen, sometime it will be running in forward, another time second it will be running in reverse. This concept you can see in the fan, because sometimes there will be unbalanced voltage in the happen. During the time the fan will be running in backward as well as should be in forward also. Okay, both the directions it will be run, because these are all the technical problem. Okay, technical issues in single phase induction motor. To overcome this technical issues in self starting mechanism in single phase induction motor, there are 4 or 5 methods which we are going to execute in this single phase induction motor. Okay, the first type, okay, there are 5 methods of single phase induction motor. Starting methods, okay, it's not a type, it is a starting methods. I understand, it is the starting methods. Starting methods of induction motor, there are 5 types. There are 5 types. The first one which we are seeing, this motor, this is a nameplate detail which is printed by the company. It is split phase induction motor. Okay, this is split phase induction motor. The second one, it is, can anyone tell what is this motor? Can anyone tell me what is the name of the motor? It's already explained in the lab class. I already explained in the lab class. What is the name of the motor which we are seeing in our somewhere in domestic application, that you have to tell where it is? What is the name of this motor? Can anyone? You see the construction, you see the picture, then you identify. Anyone? It is capacitor start induction motor. You see the capacitor here? This is a capacitor. Okay, capacitor start induction motor. The third one, it is, there are two capacitors is there. One capacitor for starting, another capacitor for running. Okay, another capacitor for running. This is capacitor start, capacitor run induction motor. Okay, capacitor start, capacitor run induction motor. Fourth one, this motor is permanent split capacitor. Permanent split capacitor means the motor is made up of permanent magnetic materials, as well as a capacitor will be inserted inside the machine. Okay, you see the remaining two motors, second and third one. Here the capacitor is fixed outside, but here it will be fixed inside. Okay, this is one of the special machine. The fifth one will be a shaded pole induction motor, which will be used mostly in some of the toys they are using it. Okay, shaded pole induction motor, as well as it is used in the laser printers also. Laser printers, Xerox machines, like that they are using it. Okay, these are the 5 types. The first one, split phase induction motor. Second one, capacitor start induction motor. Third one, capacitor start, capacitor run induction motor. Fourth one, permanent split capacitor motor. Fifth one, shaded pole induction motor. Now we'll see one by one. Split phase induction motor. You see, this is the split phase induction motor, and this is the cover, protection cover. Okay, this is a strand, and this is a supply. The wire is the supply. This is a shaft. You see this white line. Okay, this white line, call it as rotor, and this one you are seeing, right? This line will be a bearings. It will be a ball mounted type bearings. Okay, it is a ball mounted type bearings, and there are four bolts are there. You see, one, two, three, four. Okay, this is nothing but poles. Okay, this is nothing but the pole. Okay, here only the windings is available. Inside only the windings is available. It will be insulated with each other by using a porcelain materials. Stator. Okay, now the main application of this induction motor, it is having a low starting current. Is one more question. Low starting current and moderate high starting torque. Okay, if you give low starting current, then it moderates starting torque. Then these motors are used in fans, blowers. Fans means normally it will be for exhaust fans they will use. Okay, not for this ceiling fans which we are using, and industry based fans, and blowers, centrifugal pumps, and washing machines, grinders, lathe machines, air conditioners. Okay, why they are using in centrifugal pumps means, here there are two winding arrangements which I already mentioned. Okay, one is main winding, another one starting winding. Okay, so these two windings should be connected in parallel. Okay, one winding it will be connected means the another winding will be connected like this. Okay, between these two there will be a switch. Okay, there will be a switch is there. This switch is nothing but centrifugal switch, because by using the switch only we have to make phi 2 should be 0. Okay, we have to open the switch. Once you open it, you can't get a supply to this winding, so automatically the motor will start running continuously. Okay, it starts running continuously, because when the motor starts running continuously we need only one flux. Okay, we need only one flux. And these motors are available in the size ranging from 1 by 20 to 1 by 2 kilowatts. Okay, 1 by 20 means 0.05 to 0.5 kilowatts. These are all very small type of motors which is available in the market. Okay, that's what our fan cost is. If you have 1000 rupees, you can buy a good fans. Okay, and if you have 500 rupees, also nowadays for 200 also the fans are available in the market. Okay, washing machines also the same thing. Okay, the washing machine cost is 4000 rupees, a capacity of 2 kgs or 3 kg washing machines, only washing. Okay, no drying or any other options is not there. Okay, so that washing machines they will normally they will use split phase induction motors. Okay, normally in the manufacturers, okay, the goods price will be mainly depends upon the what are the parameters, that is what are the parts they are implementing in the machine, that is in the goods. For example, if you take washing machine, okay, normally if it will be a 6 kg washing machines. If you take example of washing machines, if you take 6 kg washing machines, the cost is rupees, it is almost 30k. Okay, 30k, because it mainly depends upon the equipments which will be used in the washing machine. One is motor, because for motor most of the companies will give 10 years warranty. 10 years warranty because they will use high-fi induction motors. Okay, high-fi motors they will use because the motor materials will be made up of ferromagnetic. That's what the cost is very high. Suppose the same kg 6 kg washing machine is available in the market for 10,000 also, for 10K also, but the motor they will give 2 years warranty or 1 year warranty. Maximum they will give 1 year or 2 years warranty. They won't give 10 years warranty. It's mainly depends upon the motor what they are using it for manufacture. Then the second one which we are seeing, it is a capacitor start induction motor. Okay, capacitor start induction motor, and here this is a capacitor. This is a capacitor. Through the capacitor only we have to start the machine. Okay, capacitor will be there in the top layer. Okay, so this motor I already explained in the laboratory, experiment number 1 and experiment number 2. Okay, this motor only we are using in the lab. And you see the cover here, this cover will be a cooling cover. Here fan is there, we have to protect the fan. There is a cooling cover. Okay, it will be a cover should be there in the side layer also. Application, and this motor is a high starting torque as well as high starting loads. Okay, high starting torque and high starting loads, they are used in compressors, conveyors, grinder, fan. Okay, fan means your normal ceiling fan, it will be a capacitor start induction motor. Okay, that's what when you give the supply, immediately it will take a time to rotate. Okay, because the capacitor it start moving from discharging to charging position, it will take a time. Okay, maybe a 0.5 seconds or 0.7 seconds. Okay, then only the machine you can see the speed of the fan will be increased. Now if you want to control the speed of the fan, we need a regulator, that is secondary. Like that it will be used in blowers, refrigerator, air conditioners also. The third one, it is capacitor start, capacitor run induction motor. Capacitor start, capacitor run induction motor. This is a pictorial representation. You see a sticker, this sticker will be printed by a company. Okay, once they printed, they will just paste it. Okay, then you see a cover. Here there are two capacitor. This is my first capacitor, and this is second capacitor. Okay, second capacitor. This one capacitor for starting, another capacitor for running. See, in this machine, in this arrangement also there is will be a main winding, another one starting winding. See, for all these types there will be a two windings. Okay, main winding and starting winding. This is fixed. Okay, this is fixed. Variable is maybe a capacitors, that is a variable. Okay, for all the types, main winding and starting winding is available. Without these two windings we should not make the motor to self start. Okay, then application, and here you see in this motor there will be a small holes are there, right? Okay, a space. This is for cooling purpose because some heat will be there inside the machine. Okay, we have to evacuate or we have to release the heat from the inside the machine to outside. So for that, this manufacturer they will done the cooling arrangement here itself. Okay, instead of fan they just make a design arrangement itself. They make a proper dimension as a hole. Okay, the holes are very big, and based upon these holes, the whatever the heat will be there, it will be released, it will be coming through this holes. Okay, this for cooling purpose. Okay, this is a standard, and these motors are very high starting torque. Okay, these motors are very high starting torque, so it will be used only in conveyors, grinder. Okay, don't think all the motors are used in grinder. Yes, it is used in grinders, but that is for different applications. One for domestic, another for industry, another for commercial purposes also. The grinders are available. Yeah, there will be large, big grinders are available in the college or in the hostels, whatever it may be. Okay, so the grinders and air conditioners. Air conditioners means it is not only for domestic as well as for central air conditioners are there, light. Okay, that air compressors, etc. The rating of these motors are up to 6 kilowatt it is available. Okay, the cost of the motor is very high. The cost is very high. The reason is a capacitor. Okay, but this capacitor is one of the dangerous problem, because this capacitor is a passive element. We know there are three elements are there in electrical engineering. Three elements are there in electrical engineering, passive elements. What are they? Can anyone tell me? What are the passive elements? Because active elements means voltage source, current source. Okay, that is power supplied. Okay, and power delivered. That is nothing but active. Passive element means, what is passive element? Anyone? Jimran? Jibran? Can anyone? Passive elements, can anyone tell me? Anyone? Jibran? Please give a reply. Jibran? Register number, I don't know. Next, Shushma. Passive elements. What are the passive elements are available? Anirudh. Passive elements. What are the passive elements that are available? Resistor, resistor, inductor, and capacitor. Capacitor. So resistor is a element. Resistor is a element which is available inside the winding arrangement itself. Because winding means, okay, the winding means it will be having a, what is winding? It is a copper wires are there. This is a winding. Okay, it will be like that. Okay, or we can say it will be a coil. You can say it will be a coil or winding, whatever it may be. Okay, this one winding, it is having a combination of both resistor and inductor, or XL or XL. Okay, so the combination of these two we can write impedance, or Z equal to R plus J into XL. Okay, this is nothing but because the inductance is a property which stores energy in the magnetic field. Okay, energy in the magnetic field. Due to this, our flux will be produced inside the machine. Inside the machine the flux is produced, that is nothing but rotating magnetic field. But capacitor, which is the property which stores energy in electric field. Energy in electric field. So the capacitor, it is applicable to integration. Okay, but inductor, it is applicable to differentiation, d by dt. Okay, integration means this is a lower limit, another one is upper limit. Lower limit stands for discharging, upper limit stands for charging. Okay, so because of this capacitor, it is having it in the top layer, because this is a construction arrangement designed by the company. Okay, it is a designed by the company. Okay, now by having the capacitor, we are having the rights to start and stop. Both options it is enabled. Okay, in this machine. Okay, that's what the machine cost is very high. It is 6 kilowatt machine. As well as if any problem has been happened, for example, if a high voltage is applied, immediately the capacitors will be blast. It will be blasted. That's what most of the time during midnight time you can see the newspaper. Some accidents will be happen. A person will be used air conditioners. Okay, air conditioner during night time like that. The reason he purchased the air conditioner with a capacitor type machines. Okay, when high voltage enter during midnight time, okay, what, because everybody is sleeping, right? When high voltage enter, first it will be enter into the winding, then there will be a small type of heat, as well as some heating effect, some wiring smell. Okay, it will be a brisk efferences is coming from this winding. If you are not noticed, then immediately it will be affect the capacitor. This capacitor will be blast. Once a capacitor will be blast, that is nothing but accident. Okay, so we should be very careful to handling this capacitor start, capacitor run induction motor. Okay, capacitor start, capacitor run induction motor. Okay, but what happened to the fan? Yeah, fan is also having capacitor start induction motor. When high voltage enter to our houses, the first it will be affect the fan, because sometimes the fan not running. You will get a somewhat, what is that, some little bit of mark, or otherwise you can see, yeah, there will be a bad smell is coming from the fan. Okay, something it will be happen, it won't run. Okay, because that's what the cost is very low. The cost is very low. Okay, if you call the technician also, they will say, sir, it is just 1,000 rupees, you can't do the changes there, you have to throw it in our dustbin. These are all the drawbacks in these machines. Then fourth one is permanent split capacitor. This is a permanent split capacitor motor which is normally used in a packaging industries. They are using it, and the main application is that here no centrifugal switch is needed. Okay, no centrifugal switch is needed, and it has very high efficiency and pull-out torque. It only finds application in fans and blowers, in heaters and air conditioners. Heaters means it will be a domestic heaters, not industry heaters. It will be used in domestic heaters. We are using it. It is a V-Guard or a GE like that. Okay. It is also used to drive office machinery. Any doubts? Any doubts? And what is the difference between difference between the split phase induction motor, capacitor start induction motor, capacitor start, capacitor run induction motor? Means for all these three types we are using the centrifugal switch, but here we are not using any centrifugal switch. Okay, so centrifugal switch is absent. Without centrifugal switch we are operating it. That is nothing but permanent split capacitor motor. Fifth one, it is shaded pole induction motor. Okay, this is the shaded pole induction motor. You see the motor size is very much small. Okay, it is very small. Okay, here you see this is a winding. Here only winding, like transformer, it's a winding, and this is the shaft. This is a bearing. The structure of this, it will be a square type structure. Okay, it will be a square type structure, remaining all rotating structure, but this shaded pole it will be a square type structure. The application for this, due to low starting torques and a reasonable cost, it is mostly used in small instruments, hair dryers, toys, recording players, small fans, small table fans, and electric clocks, etc. Okay, it is mostly used in domestic. Domestic means not our home applications. It is used for a small domestic applications like toys, hair dryers, and your hammers. Okay, like that. Okay, it will be useful. Any doubts? And in this machine shaded pole, there will be a centrifugal switch will be there. Okay, there is a centrifugal switch. Okay, so in next class I'm going to explain step by step, okay, how what is meant by a split phase induction motor, and how it is constructed, and what is meant by a principle, and how it is operated, what are the advantages, disadvantages, application. So like that, there are 4 lectures which we have scheduled for upcoming days. Okay, this lecture is only for types. Types means, I already mentioned, it is starting. We have to say starting methods of induction motor. In your examination, I will ask the question like that. Discuss the starting methods of single phase induction motor in detail. Okay, in detail. For 5 mark question means you have to explain the reason what I mentioned in the slide number 2. Okay. Any doubts? And the range of this motor is very small. Okay, 1 bar 300 to 1 bar 20 kilowatt. Okay, very small type of ratings. Okay, 1 bar 300 means it comes around 0.003. Okay, 0.003 kilowatt machine. It is very small minute machines. Okay, okay, it is easily made up of for you for making the toys. Okay, toys and hair dryers. Okay, our this one what is that, a trimmer. Okay, we are using the trimmer, right? The trimmer cost is 500 rupees. If you check in Amazon, it comes around 200, 300 also be there. The reason is that depends upon the motor, not for the what is that, the company or whatever it may be. Okay, the every all the electrical or electronic goods will be, the cost of the electrical and electronic goods will be decided based upon the motor which they are using inside the product. Any doubts? Any doubts? Here also there are 2 windings. One is main winding, another one is static winding. Any doubts, ma? Any clarifications?